In this video, we're going to talk about naming and formulas for molecular compounds, otherwise known as covalent compounds. So these contain two or more non-metal atoms, and the electrons are shared by the atoms. So remember, with ionic compounds, we had electron transfer. Now we have electrons being shared. The electrons are shared in order to satisfy the octet rule. And the sharing of electrons creates covalent bonds. So when we share electrons, we take one of the unpaired electrons from one of the nonmetals and the unpaired electron from another nonmetal. We pair them up and share them like this, such that both of these nonmetals now have a full octet. And these are molecules, and they are formed from covalently bound atoms. We can have diatomic molecules, which are two atoms covalently bonded together, or polyatomic molecules, which are more than two atoms covalently bonded together. So some diatomic elements, which are elements that always exist naturally as diatomic molecules. These are ones that you will have to remember. So H2, so we always write it H2 because it's two hydrogen atoms covalently bonded together. N2 is two nitrogen atoms covalently bonded together. O2 is two oxygen atoms covalently bonded together. F2, Cl2, Br2, and I2. The halogens are always two atoms covalently bonded together. So remember, these are the ways that these exist in nature. So you pretty much never come across just a hydrogen atom. It's always as H2. Same with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So when we come up with the formulas for these, the steps that we want to do is write these symbols in order of the elements in the name, then write any prefixes as subscripts. So what I mean by prefixes are these. So if we have just one atom present in the molecule, then we use mono. If there's two, it's di, 3 tri, 4 tetra, 5 penta, 6 hexa, and so on. But remember that we only use these prefixes when naming molecular compounds, so we do not use these for ionic compounds. And also the mono prefix will not come before the atom if it's the first atom in our formula. So you would not use the mono if you have just, say, a single carbon as the first atom in our chemical formula. So let's go through a few examples for these. So we have carbon dioxide. So we see we have that di prefix there. We do not have a prefix in front of the carbon. So that means we only have one carbon. The di tells us that we have two oxygens. So that would be CO2, where the 2 comes from the di prefix. The next one, we have dinitrogen tetroxide, and this is something that you have to get used to. We saw before that the prefix is tetra, but when we're using oxygen, they usually leave off that A, just call it tetroxide. That's just because it kind of rolls off the tongue better. So this means we have 2 nitrogens and 4 oxygens, so that would be N2O4. Then the next one, we have carbon tetrachloride. Again, there is no mono in front of the carbon, so that means there is one carbon because this is the first atom listed in the name. Then we have tetrachloride here, so that means we have one carbon and 4 chlorines. So that's CCl4. The next one, we have disulfur dioxide, so that means we have 2 sulfurs and 2 oxygens. So S2O2 for that one. Then if we want to come up with names from the formulas, the first step is to name the first nonmetal by its element name, and then the second step is to name the second nonmetal using the first syllable of its element name, followed by "ide." Step 3 is to add prefixes to indicate the number of atoms, and the number will be indicated by the subscript. But remember, if the first atom listed only has one, we do not use the mono prefix. So we'll go through a few examples here. We have N2O3. That means we have 2 nitrogens, 3 oxygens. So that would be dinitrogen trioxide. The next one, we have 1 sulfur and 2 oxygens. So that means we have sulfur dioxide. Again, we have only 1 sulfur, and it's at the beginning of the formula, so we don't use the mono prefix for it. And the next one we have F2O, so that means we have two fluorines, one oxygen, so we call this difluorine monoxide. Though you will also see this called oxygen difluoride, which will be written as OF2. So you'll see this one kind of used in both ways, but if we have it written as F2O, we would want to call it difluorine monoxide. The next one we have just CO, which means that we just have one carbon, one oxygen. Again, the carbon does not get the prefix mono, but the oxygen does because it's written second. So carbon monoxide here. There are three molecular compounds that have common names that you have to learn. So there would technically be a sort of systematic name for these, but they're pretty much always just called by these common names. So these are ones that you have to remember. So one of them is water, that's H2O. The systematic name would be dihydrogen monoxide, but you pretty much never see it called that. The next one is ammonia. Again, the systematic name would be something like nitrogen trihydride, but you almost never see it written that way. Then methane CH4, the systematic name would be carbon tetrahydride, but again, you never see it written that way. So you do want to memorize these ones as the common names. So here are some practice problems you want to fill in this table. Again, I encourage you to pause the video and try these on your own before watching the rest of the video where I will answer these. So the first one, we have P4O6. We have 4 phosphorus and 6 oxygens, so that would be tetraphosphorus hexoxide. The next one, we have 2 phosphorus and 3 oxygen, so that would be diphosphorus trioxide. The next one, we have carbon tetrafluoride. So again, there is no mono prefix in front of the carbon, but we know that there's just one because there's no prefix in front of it. Then tetrafluoride tells us that we have 4 fluorines, so that'd be CF4. The next one, silicon dioxide. We have 1 silicon, 2 oxygens, so just SiO2. The next one, we have S2O3, so 2 sulfurs, 3 oxygens, so that would be disulfur trioxide. The next one, H2O. This is one of the ones where we have to use the common name, so it's just water. The next one, we have 1 selenium, 2 oxygens, so it would just be selenium dioxide. The next one, CH4, that's another one that we need to know the common name for, so that's just methane. The next one, we have nitrogen dioxide, so just 1 nitrogen, 2 oxygens, that's NO2. The next one, we have O2, so you might be tempted to call this oxide or dioxide or something, but when we have one of these diatomic molecules, we just want to call it by the name for it. So remember, oxygen is one that always exists as a diatomic molecule, and so if you see O2, you want to call it oxygen. If you see N2, you just want to call it nitrogen, and so on and so forth. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.